solve this equation. And you notice it's kind of like a quadratic. You have something to the fourth, something squared, and a constant. So we can treat it like a slip and slide. So that's x to the fourth minus 5x squared minus 36. So multiply to negative 36, add to negative 5 would be negative 9 and positive 4. Because it's an x to the fourth, that breaks into x squared. Now remember to undo your slip and slide. You start out multiplying by 4, so we divide the 4 back. So then you can set each of those to 0. So if we solve this, we get x squared equals 9/4. Square root plus and minus, so that's plus and minus 3/2. This one, x squared equals negative 1. Square root plus and minus the square root of negative 1 is I. So remember that power tells you how many solutions. Since it's an x to the fourth, I expect 4 solutions, and that's how we get there. Any questions on that one? So let's look at 4b. So we have a radical. On our radical problems, our strategy is to get rid of the radical. So we isolate it, which it is. Opposite of a cube root is to cube. So if we cube each side, that gives us x squared plus 3x equals 5. So if we subtract over the 5. And when you try to factor, nothing multiplies 5 and adds to 3. So that's when you have to do the quadratic formula. This is one that we should know. So the opposite of b, plus or minus the square root, b squared minus 4ac, all over 2a. So the opposite of 3 would be negative 3, plus or minus the square root. 3 squared minus 4 times 1 times negative 5 over 2 times 1. Okay, so this would give me 9 plus 20. You always break down your radicals if you can. 29 is prime, so that won't reduce, and that would be our final answer. Remember on those radical problems, you need to be checking. This one actually works fine because it's a cube root. It's when you have square roots and you start squaring that sometimes your answers don't work. So like for A, you actually got 2 answers, negative 5 and 2. But when you checked them, only the 2 worked. So make sure if you're adding squares in your equations that you do check your answers. If we look at C. So the first thing you have to do is get the square root by itself. So in order to do that, what do I have to do? Subtract over the 5. Then we can square, and as soon as I square each side, I'm going to make myself a note that I have to check at the end. So over here, those cancel, and we get 3x plus 4. Here you have to write that twice in FOIL. So you get 4x squared minus 16x plus 16. We always set our quadratics equal to 0, so if we subtract over the 3x, subtract the 4, then we could do slip and slide. So multiply to a positive 48, add to a negative 19. What works? We start out multiplying the 4, so we divide our 4 back. So we get x minus 4, 4x minus 3 equals 0. Set each of those to 0, and we get positive 4 and positive 3/4. But when you check, you don't have to show me the work for checking. You can just do it on the calculator if you want, but you're putting it in. So if you put in a 4, you get the square root of 16 equals 8 minus 4, and that works. If you put in a 3/4 though, does that one check out? Because the side turns out to be negative. So that solution gets thrown out, and 4 is the only one that works. Is that okay with everybody? D. The problem I saw on this one was the exponent. There are a couple different ways to do it. You could actually just try to do slip and slide from here, but I think almost everyone rewrote it without the negative exponents. However, negative exponents make something go to the bottom. When I look at this, the x has a negative exponent, so the x goes down to the bottom. So it's 15 over x squared. 19x to the negative 1 would be 19 over x. So easiest option here would probably be to take everything times x squared. When you do that, you get 15 minus 19x plus 6x squared equals 0. Or if you flip it around so it looks more like a normal quadratic. Then we can slip and slide. Multiply to 90, add to negative 19. Will be negative 9 and negative 10. Divide back our 6. So 9 over 6 reduces to 3 over 2, so 2x minus 3. 10 over 6 reduces to 5 over 3, so 3x minus 5. Set those to 0 and you get 3 halves and 5 thirds. And you could certainly check those. Plug them back in the original and they do both work. Questions there? Let's talk about number 5. So the definition of logs is really, really important to know. If you don't know the definition, you can't solve any of the log problems. And so you always start with the base. Okay, if you're talking about an exponential, the base is the thing being raised to a power. If you're talking about a log, it's a little subscript. If we have ln, what's that little subscript? E. So either way, we're starting there. And then we always drew in these arrows. It just goes across the equal sign and back. Across the equal sign and back, no matter which way you're going. So this one I was trying to write it as a log. So we start with a log. The number I highlighted, my base becomes my subscript. Go across the equal sign, so 1 over 625 equals negative 4. Okay, a log is giving you an exponent. When it's written the other way and I'm telling you to get rid of the log, you start with the e, go across the equal sign, that's your exponent, equals x. So that's something you just have to know what the definition is. That's what a log is. It's that operation. So make sure if you've struggled with that you look back over it, and I can even give you some more to practice if you need it before the final. Then we started solving the log and exponential equations. So number 6, there's a couple ways to do this one. Some people just looked at it and wrote down the answer. If you know what a log means, it's asking for the exponent. It means 4 to what power equals 1 over 16. So if you recognize that, what is that power? Negative 2. If you didn't, you write it as an exponential. You start with your base and you go across the equal sign. So it's 4 to the y power equals 1 over 16. And when we solve these, we got a common base. We know 16 is 4 squared. Since it was on the bottom, it would be a negative 2. So y is negative 2. that okay? Problem 11. When we had these log problems, we started out using the properties of logs to condense as much as possible. If you have two logs being subtracted, how do you put those together? Division. So that's the natural log of x plus 7 divided by 3. You write the log once in front, you divide those arguments. But now what I see is I have a log on each side, which means we can really drop that. These arguments are equal. So if you want to get rid of your fraction, you can multiply your 3. X plus 7. That's 21x plus 3. I'm pretty sure I put this exact question on a test, and I would say like a third of you missed it because you worked it all out, and then at the very end you made a mistake. You subtract over your 3, you subtract your x, and right here when you divide by 20, what's your answer? 1/5. On the test, like a third if you put 5 on that question, so just be careful. What should we always do on these log problems? Check them. When you have a log, the argument has to be positive. So 1/5 plus 7 is positive, 3 is positive, 7 times 5 plus 1 is positive. So it's all good. If any of those turned out to be negative, then we would say there is no solution. So this starts out, it's an exponential, and we would try to do it like you did question number 9. You know, can I get a common base here? But we can't. So if we can't get a common base, our strategy was to add a log to each side. The reason we like logs is then the exponents come down in front. On this side, we have to distribute our log. So 1 times log 3 is log 3. Negative 2x times log 3 is just negative 2x log 3. Equals x log 4. Trying to get my x's together. Both of those terms have an x. They're not like terms, but we can put them on the same side. Then what can we do? So right now we have x times something. Opposite of multiplying is dividing. So to get x by itself, we divide that whole thing over. So we have log 3 over log 4 plus 2 log 3. And we talked a lot about when you put these in the calculator, it always opens up parentheses, so you need to make sure you close it. You either need to make sure you're viewing it as a fraction or add a second set of parentheses around the whole denominator because it's more than one term.
Sounds like we're having a good time.
Yeah, I think so. Any questions?
If we ever have to round on the test, will you tell us what we need to round to?
Yeah.
Okay.
And if I don't, 3 to 4 decimal places is fine.
Any questions?
Our last question you guys asked me about, problem 16, solving a system, substitution and elimination. So we have 3 equations. If you notice, the second equation already doesn't have what variable? Z. And the third one doesn't have y. So we start by picking any 2 and eliminating a variable. If I just pick the first 2, what variable would you want to eliminate? You can eliminate x or y. Those are your 2 options. You'll get the same answer either way. Is one option easier than the other? Why? Just because it already eliminates. But if you chose to eliminate x, all you have to do is multiply the second one times -5. So no big deal there. So if I add those together, 5x plus x is 6x. My y's cancel. My z equals 5. I have to use this third equation. But it only has x and z, and look at the answer we just got. It has x and z, so let's put those 2 together. If I want to eliminate z, what would I do? So I'm taking that third equation. I'm going to take the answer I just got times -3. If we add those together, we get -16x equals -13. Divide, and x is 13/16. That's probably when you thought you did something wrong because it was a weird answer, but it's not wrong. That is correct. So remember our answers, we do x, y, z. So we have x, we have to find y and z. And probably the easiest option is to plug it back into one of these to get our z. So if I just went here, 6 times 13/16 minus z equals 5. Alright, 6 times 13/16. What does that give me? 39/8. Subtract that over, we get z to be -z equals 1/8. Divide by the negative. So z is -1/8. So I have my x and my z. We need y. Which one would be the easiest to plug it into to get y? First or even second is just x plus y. So it doesn't matter, you have to do either the first or second to get your y. So if I did the second one, x 13/16 plus y equals 5. So if we subtract that over, 67/16. Anything else on that first chunk of problems? So now you guys have time to work on